Section 1 on right triangle trigonometry. So first thing we're going to do is look at the three main trigonometric functions, and these three functions come from a right triangle by labeling one of the angles theta, that's the circle with the line through it, and from that angle we label the opposite side, which is across from the angle, adjacent, which is right next to, and the hypotenuse, which is always across from the right angle. Using those sides, then we have the trigonometric function sine is the ratio of the opposite side to the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. We can use these trig functions to solve for missing sides of right triangles and for missing angles. Here are three more trig functions. The cosecant of an angle is the hypotenuse over the opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. You will notice that these three functions are actually the reciprocal of the first three, so you don't have to do extra work if you need to get these three trig functions. You can just take the reciprocal of the original three. Okay, so example 1 says to find the exact values of the 6 trig functions of theta. So the first thing I do when I have a triangle is to label from that angle the opposite and adjacent and hypotenuse of that triangle from that angle. Okay, then we can find those exact values of the trig functions. Now we're not solving for anything in our calculator, we're just going to write the trig ratios and reduce the fraction if necessary. So the sine of the angle is opposite over hypotenuse, so that's going to be 33 over 65. Cosine of theta is adjacent over hypotenuse, so that will be 56 over 65. And tangent is opposite over adjacent, which is 33 over 56. So because I have these three trig functions, the other three are the reciprocals, so I can just flip these answers over and I'll have the other trig functions. So the reciprocal of sine is cosecant, and that's going to be 56 over 33. The reciprocal of cosine is secant, which is 65 over 56. And the reciprocal of tangent is cotangent, which will be 56 over 33. So, if at all possible, you need to reduce your fractions or simplify any radicals that might be in your fractions, but these are the exact values for the 6 trig functions. Number 2 gives us that the sine of some angle is 1/3, and they want us to find the exact values of the other 5 trig functions for that acute angle. So I would draw a triangle and label one angle theta, and usually it's going to be one of the acute angles. We're not going to label from the right angle. Okay, I'm going to label 1 and 3 for the opposite and the hypotenuse, since they gave me that the sine ratio was 1/3. So I need to solve for the missing side of the triangle. I'm going to use Pythagorean theorem. So 1 squared plus x squared equals 3 squared. 1 plus x squared will equal 9. X squared equals 8. If I take the square root of both sides, remember when we take the square root, it's the positive and negative square root of 8. But since we're talking about a triangle, we're not going to use the negative value. Okay, so the square root of 8 simplifies and reduces to 2 square root of 2. So that's our missing side of our triangle. Now that we have all sides of the triangle, I can write the ratios. So they told us that sine was 1/3, so that means that its reciprocal cosecant is 3 over 1, or 3. Cosine of the angle will be adjacent over hypotenuse, so that's going to be 2 square root of 2 over 3. The reciprocal of cosine is secant, so I flip that over, 3 over 2 square root of 2. Now, it is improper in math to leave a radical in the denominator, so to fix that, we multiply by the radical on the top and bottom and simplify. So this will become 3 square root of 2 over 4. Okay, tangent of the angle is opposite over adjacent, so that's going to be 1 over 2 square root of 2. Again, I can't leave the radical in the denominator, so I'm going to multiply by the square root of 2 on top and bottom. So this becomes the square root of 2 over 4. The reciprocal of tangent is cotangent, so I need to flip over my tangent to get the cotangent. I'm not going to flip over the square root of 2 over 4 because I would wind up with a radical in the denominator again. So I go back to the original problem, 1 over 2 square root of 2, and I flip that, which is 2 square root of 2 over 1, and that just equals 2 square root of 2. So the next thing we're going to look at is special right triangles. In geometry, you learned about a 30, 60, 90 and a 45, 45, 90. We're going to be using these a lot in the next couple of chapters. And you may not have seen this picture with the X's representing the sides, but you learned some of the rules for these triangles. So you learned that in a 30, 60, 90 that the longer leg is always the square root of 3 times the short leg, and that the hypotenuse is always 2 times the short leg. In a 45, 45, 90, the two legs are congruent, and the hypotenuse is always the square root of 2 times the leg. Okay, so we could go through those rules and write all of the trig ratios for these angles, but I've given you a chart here for the trig values of the special right triangles. These values you will need to memorize. My suggestion is to memorize the sine, cosine, and tangent, and if you have those memorized, then the cosecant, secant, and cotangent you will automatically know just by flipping over those values. Okay, so example 3 says to find the value of x. We're going to be solving for the missing hypotenuse in this triangle. So again, always label from the angle that you're given. We're also going to need to be in degree mode when we're solving these problems right now. So make sure your calculator is in degrees. So from 41, 7 is the opposite side and x is the hypotenuse. So I have to think about what trig ratio I could use to solve this problem. Opposite over hypotenuse is sine, so I'm going to write the sine of 41 degrees equals 7 over x. And my goal is to solve for x. So I'm going to multiply by x on both sides. So then I'm going to have x times the sine of 41 equals 7. I'm going to divide by the sine of 41 on both sides. So x equals 7 over sine 41. So in my calculator, I type 7 divided by sine 41, and I'm going to round to the nearest tenth. This is approximately 10.7. Okay, number 4, same thing. This time we are going to solve for the missing angle theta. We still want to label from the angle that we're solving for or the angle that we're given. So 12 is opposite and 15.7 is the hypotenuse. So again, this is going to be the sine function. Always figure out what pieces you're given and let that determine what trig ratio you're going to use. So sine of theta is going to equal opposite over hypotenuse, so that's 12 over 15.7. So since we're solving for the angle theta, we can't divide by sine on both sides. It's not a number or a variable, it's a function. So we have to do the inverse function on both sides, which is sine inverse. So that will cancel the sines on the left-hand side with sine inverse, and we'll be left with theta equals sine inverse of 12 over 15.7. So in your calculator, you're going to type second sine 12 divided by 15.7. And this says to round to the nearest degree. I forgot to round to the nearest degree, and I rounded and wrote 49.8. But this would round up to 50 degrees. Okay, last example says to solve triangle ABC. So when it says to solve the triangle, that means you're solving for all of the missing sides and angles for the triangle. So I noticed that they gave me two sides. So first thing I want to do is use the Pythagorean theorem to find the missing side. So 5 squared plus 9 squared is going to equal BC squared. So 25 plus 81 equals BC squared. And this is 106. So I take the square root of 106, and always want to see if you can simplify your radical. So I'm going to factor 106. 2 goes into 106 53 times, and 53 is a prime number. So since there are no pairs here that I can pull out of the radical, this is just going to stay the square root of 106. Always check to make sure that you can simplify your radical first. Okay, now that I have all the sides, I need to start working on the angles. So I'm going to label from angle B, opposite and adjacent. I'm not going to use the hypotenuse since I solved for that myself. I always want to go back to the original information that they gave me in the problem. So since I have the opposite and the adjacent side, that's the tangent ratio. So I'm going to write tangent of angle B equals 5 over 9. And like previously, when we're solving for an angle, this is where we're going to use the inverse function. So B will equal inverse tangent of 5 over 9. So B turns out to be approximately 29 degrees. Okay, now I'm solving for angle C. So when I label from angle C, my opposite and adjacent are actually going to switch places. So it's still going to be tangent of angle C is 9 over 5. So in my calculator, I'm going to do inverse tangent of 9 over 5, and I get that C is approximately 61 degrees. You can also know that that's correct because angles B and C should add to equal 90 degrees. All three angles in the triangle should add to equal 180 degrees.